One of the most difficult subjects for private pilots to understand is definitely radio navigation. It is quite important, though, to learn how to navigate by use of instruments rather than landmarks, in the case you get lost, and also, and most importantly in our case, to pass the test. There are many questions during the written that go over radio navigation. So, let us show you how we transform these complicated instruments into something we promise you will want to use right away on your next flight.
Very high-frequency omnidirectional ranges, VORs, are the primary means of radio navigation. They operate in the frequency range of 108.0 MHz to 117.95 MHz. Because they operate in such a high frequency, they are susceptible to line of sight. So, for example, if there is a large obstacle between you and the VOR, say a mountain, you will not be able to receive that VOR. By identifying the signal of the VOR, it will send out a 3-letter Morse code identifier. If you're able to identify it, then that VOR is working properly. If you cannot identify it, it's probably not usable.
How does a VOR do what it does? Well, a VOR sends out two signals. One is continuous, and the other one is modulated. Let's think of them as waves. And on the 360-degree radial, these waves are right on top of each other. As you move to the 90-degree radial, these waves are 90 degrees offset from each other. At the 180, they're 180 degrees off. Your receiver works kind of like an oscilloscope and sees how much in phase or out of phase these two signals are. And by seeing the phase or out of phase, it can tell you exactly what your position is from this VOR.
VOR receiver checks. A VOR needs to be checked every 30 days. There are multiple ways of checking a VOR. There's airborne checks, ground checks, VOTs, and made-up checks. But the test for the private only deals with one type of check. So that's the only one that we're going to discuss, so I don't go and confuse you. The test deals with the VOT check. A VOT is a short-range VOR located at some of the nation's airports. And no matter where you are on that airport surface, when you tune to it, the needle will center with a to indication on the 180-degree radial, and with a from indication, obviously, with the opposite, the 360-degree radial. Now the way to remember this is remember a Cessna 182. 180 is to the station, and the maximum allowable error is plus minus 4 degrees.
Okay, how exactly do we figure out our position relative to a VOR? As I said at the beginning, I'm going to have to ask you to forget everything you know about a VOR. Trust me, this system is so much simpler than what you're used to. Think about it. The needle points to the right, you go to the right. The needle goes to the left, you go to the left. Oh wait, but you might be in reverse sensing. That's if the flag has a from instead of a to. Come on, this is complete nonsense. How does a VOR work? It's very simple. Let's say that I ask you, what is your position relative to me? And let's say I'm in Texas and you're in Maine. Well, your simplest answer would be to say that you are northeast of me. Well, that's exactly what a VOR does. For example, this VOR is telling me that it is located to the northeast of me. How do I know it? It's incredibly simple. A VOR, like you before giving me two cardinal directions to get to you, is giving me a couple of cardinal directions telling me where it's located. In this case, the VOR is telling me that it's north and east of me. How do I know this? Well, first of all, that little to from flag, let's just call it a flag and forget that there is a to from on it. It's just a flag. It's one of the indicators that directs you towards the VOR. In this case, as you see, it is pointing down. So I look at a cardinal direction on the same side that that flag is pointing to. If I go straight down from that flag, I can see that it's saying, hey, go north. That is one of the two cardinal directions that we must use to go to that station. The second cardinal direction is shown by the needle. The needle will swing to one side. You must find a number on that side, and in this case it's evident that east is on that side. So I found one cardinal direction for the flag, north, the other one for the needle, east. This VOR is telling me it's northeast of me. It is that simple.
Now I'm going to give you another thorough explanation on how we use this method so everything gets clear. Remember, you need to forget what you know. First of all, do you see that to from flag? Do you see the to and the from on that instrument? No, you don't. That to and from does not exist, okay? That's the first step you need to do. Realize that there is no to from. Second, we look at what side the flag is pointing to. As you see, the flag is pointing straight up. This pretty much means that the cardinal direction it's pointing to will be on the top side of the instrument. The bottom 180 degree of the instrument you can black out because our cardinal direction cannot belong in the bottom side of the instrument. Now, straight from the top, if we look for a cardinal direction, the closest cardinal direction to the top of the instrument is what? We have west on that side and south on that side, but the closest cardinal direction to me is south. That's one of the cardinal directions. We need to go south to get to the station. Okay, south is one of the two cardinal directions we are required to fly to get to that station. Now we're going to look at the needle. Okay, now we're looking at the needle, and the needle is on the left side. This eliminates the right 180 degree side of the instrument, meaning our cardinal direction, the second cardinal direction that we're looking for, cannot be on that side there, and that's why it's gone. The cardinal direction is on the left side. If I go straight to the middle of that and find the closest cardinal direction to the middle, as you see, east is on that side. If we want to fly to the station, we need to fly south and east, putting us northwest of the station.
Okay, let's look at, for example, a question to see how this method actually helps us. Let's say, given the following VOR, you're asked to identify what your position is, and possible answers are 8, 12, or 2. Okay, again, I'm going to look at my VOR. As we see, the flag points towards the south, meaning I must be north of the station. And the needle points towards the west, so I'm east of the station. So for me to fly to the station, I would have to fly southwest. Well, then I have to be northeast of the station. If I have to be northeast of the station and I look at the three answers, the only answer that matches is answer number 8.
Now let's see if you got the point. Tap on the correct answer.
Okay, this one here is incredibly easy. It says, refer to figure 27, areas 4 and 2, and figure 29. The VOR is tuned to Jamestown VOR, and the aircraft is positioned over Cooperstown's airport. Which VOR indication is correct? 1, 4, or 6? Well, you can see from the figure that Cooperstown Airport is obviously to the northeast of the VOR. As shown by this line, you would have to fly southwest to get to it. But let's not even put the west part. We know that we have to fly south. So, look at VOR number 1 and VOR number 4. Do you see those flags? They're pointing straight up. If we look for that cardinal direction, it's north in both cases. Well, if you fly north from Cooperstown, if you have enough gas to circle the world, eventually you'll get to the VOR. You're going for the North Pole, and yeah, probably not a good idea. So you have to fly south. C, number 6, if you look at that flag now, that flag is actually pointing down. What's down there?
South. So instrument number 6 is your correct instrument.
This one might seem a little more complicated, but in reality, it's just as easy. It says, refer to Figure 21, Area 3, and Figure 29. The VOR is tuned to Elizabeth City VOR, and the aircraft is positioned over Showboro. Which VOR indication is correct? 2, 5, or 9? Showboro is just a city, and we see that if we have to fly from Showboro to the VOR, which is located at the airport, we need to again fly southwest. Okay, if we look at VOR number 2, it's showing, if we look at the flag is pointing down it shows exactly 2 and 0, which, by the way, if I extend another line from the airport, same as the first line that had us fly to the airport, you can see that it points exactly to 210. So 210 is our heading to the station. So VOR number 2 is definitely correct. Now, if we look at the other 2 VORs, by looking at the flags, they're pointing towards the north in both cases. Again, we need to fly south-southwest, not north. Look at those 2 other, and they're pointing north. So again, VOR number 2 must be our correct answer. And let's go over some other test questions. For example, this one here says, refer to Figure 24. What is the appropriate position of the aircraft if the VOR receivers indicate the 320 radial from Savannah VORTAC, Area 3, and the 184 radial of Allendale, VOR Area 1? They give you these 3 answers. This is very simple. What we're going to do is we're going to draw out a line from the Savannah VORTAC, extending out from the center of the VORTAC all the way to intersecting the 320 line of that radial, and we'll extend it all the way to a certain point, and do the same with the second VOR from the Allendale VOR. We'll extend a line from that goes down from 184, from the center of the VOR down to the radial 184 until it intersects the first line that we drew. That point there is where we are located. As you can see in the answers, the town of Springfield is the closest to where we found our point to be. So we are over the town of Springfield. Okay, for this question here, there's a complicated version and an easy version for the answer. I just wanted to give you a little bit of information more than I'll tell you the easy way to solve this. But anyway, as you can see, there is no to from flag. So we only have one indicator in this case, only a needle. What's happening is you are in the zone of ambiguity. It means that you are 90 degrees, your position is 90 degrees from the selected radial. And in this area here, as you can see between the 2 yellow lines, the VOR gets confused because if you go a little bit south of the yellow line, then it will show an indication to go north on the to from flag. If you go a little bit north, the opposite would be true. This is called a zone of ambiguity. Now, if you look at the needle itself, for the easy solution to this question, if you, let's say, before I told you to use the flag for one of the indications and the needle for the second. Since we don't have a flag this time, we can just use the needle. If you look at where the needle is pointing to about 300, so northwest. Well, if the needle is telling you that you need to go northwest to go to the station, you have to be southeast. Now let's cover ADFs. And, well, before we get into the pulp and to the juice of this instrument, we do have to cover some basics and some ADF terms that you will have to become acquainted with. There are 3 really. One is MH, the other one is RB, and the last one is MB. These 3 are what constitutes a formula that we will eliminate as soon as you get to know it, because there's easier ways than using the formula. And that's probably why most pilots find this instrument to be not an easy to go with instrument and prefer not to use it. While in reality, this instrument is pretty easy altogether. What is MH? MH is just your magnetic heading to the station. If you tune into an NDB, your ADF is the instrument that you'll be using to fly it, and let's say that the needle is centered up straight, MH, now your magnetic heading showed by your heading indicator is the heading to the station. If the needle was not centered, now we're talking relative bearing. The relative bearing, let's say you're heading 360, and let's say the needle is 60 degrees to your left, your relative bearing would be 300 because that's what the needle points to in a fixed card ADF. The last one is magnetic bearing. Your magnetic bearing to the station would be 300 because we said our heading indicator had north on it. You were heading north, and your needle points 60 degrees to the left. That, as we see, is 300. Now, if we were to transfer that needle inside the heading indicator, it would point to 300 because both the ADF fixed card and our heading indicator are on north. It sounds complicated. I will explain in a little bit. Navigating with the ADF. Low frequency non-directional beacons, NDBs, operate in the range of frequencies of 190 to 530 kilohertz. As you see, these are low frequencies. They do go around obstacles, so line of sight is not an issue, but they don't radiate the courses and radios like a VOR. What happens is when you tune to an NDB station, the needle inside your ADF points directly to the station. The following formula can help you determine a magnetic bearing to or from a station. The formula says that if you add your magnetic heading to your relative bearing, you can find out the magnetic bearing to the station. But I don't know who would want to be doing complex operations. It's not complex, it's 1 + 1 = 2. But still, when you're in a level 5 thunderstorm and IFR conditions behind the airplane, it's probably not a good idea to be working with numbers. So I will show you a much better and easier way to figure out what your magnetic bearing is, and we will see that in the next slides. What is an RMI? Well, a radiomagnetic indicator is in fact a heading indicator with the ADF needle mounted directly inside of it, making the instrument a lot simpler. What happens is the head of the needle points directly to the station. So for example, in this case, if we had to fly to the station, we'd be using a heading of about
339.
And if we wanted to fly directly away from the station, then we would be using
a 159 heading. Just about a 159 heading.
It makes things a lot simpler once you learn how to use an RMI and understand the concepts of an RMI. Well, the easiest questions on the test regarding ADF will ask you, for example, refer to figure 31, illustration 3. The relative bearing to the station is, well, this is a fixed card ADF. So if we wanted to find out the relative bearing to the station, we just look at where the needle points to, and I can see that it's pointing to 180. So 180 is my relative bearing to the station. If the question had asked what is your relative bearing from the station, well then I look at the tail, and as you can see, the tail points to 360. Now for a little bit of a more complicated question. The question says, refer to figure 31, illustration 4. On a magnetic heading of 320, the magnetic bearing to the station is, and those are your 3 answers. The easiest way to do this, I know they've taught you that there is a formula, magnetic heading plus relative bearing equals magnetic bearing, but nobody wants to do math in an airplane, especially if you're using instruments. It's probably because you're lost or you're in bad weather. So doing math in those conditions are going to set you even more behind the airplane. So how do we solve this? The first thing you need to do is draw out a heading indicator with a heading of 320 on top. Or again, you could just use our CD and rotate the CD until you have the correct heading on top, the heading given by the question. Second, we're going to move the needle from inside the ADF card into the heading indicator. We have created an RMI this way. So now, wherever the needle points to inside your heading indicator is your magnetic bearing to the station. So, in the case here, as they're asking the magnetic bearing to the station, I can clearly see without doing any math that I have to fly 185 to go to the station. So B is my correct answer. If they had asked me what is the magnetic bearing from the station, well, then again I pick the tail, and I can see that it's about
005. Some test questions really make no sense whatsoever. And let me show you what I mean. This question here says, refer to figure 30, illustration 1. What is the relative bearing to the station? I mean, why on earth would you want to know your relative bearing when you have an RMI that points directly to the magnetic bearing and therefore directly to the station? In any case, this is an actual current test question, so let's go at it and see how to solve it. Keeping in mind that the relative bearing is the number the needle points to in a fixed card ADF, which always has north on top, all we need to do is draw a heading indicator with north on top and then move the needle into it. As you can see from the animation, the relative bearing to the station, in this case, would be 240, and that's how you answer these questions. Some questions will ask you for a heading to intercept a particular bearing to the station. And before we get to an actual question, let's cover a basic concept first. As you can see from the animation, as you keep flying, the needle will drop on the same side as it's on. So you will intercept all the magnetic bearings between the head of the needle and the back of the instrument. In this case here, you will intercept bearings from 300, where the needle started from, all the way to about 151, and would never intercept the bearings on the right side of the instrument. Now to see an actual test question. This one says, refer to figure 30, illustration 2. Determine the approximate heading to intercept the 180 magnetic bearing to the station, and the answers are 040, 160, and 220. Now, if we just kept maintaining the heading shown on the instrument, we will obviously intercept the 180 bearing to the station, but that's not one of the answers. So what we need to do is turn to the headings given by the answer and see what happens to the needle. Let's start with 040. As you can see, the needle will never actually drop to 180, so that can't work. If we turn to 160, we have the same problem, with the needle dropping on the wrong side. Finally, if we turn to 220, we can see that the needle will actually drop to 180, making 220 the correct answer. Obviously, during the test, you will not have the software with the animations to help you. So, what should you do? Well, what you should do is draw out the various heading indicators with the headings given by the answers on top of them. Then, put your pen on the original magnetic bearing. In this case here, it was 190. And drop the pen on the same side of the instrument it's on until you find the correct answer.
Global Positioning System, or GPS. It was developed by the military and intended for use only by the military. But obviously, something as good as this could not be kept a secret for a long time. Now GPS is available to pretty much everybody. It's opened up to the public, and it's available to anybody that has a GPS receiver. It is very reliable and probably one of the easiest ways to navigate. It's simple in functionality. What it needs pretty much 3 to 4 satellites to figure out where you are. What your GPS receiver does is it sends out signals to various satellites, and based on the time response of these satellites, it's able to locate your position, where you are in longitude, latitude, altitude, and speed. And because of the software that comes with your GPS receiver, you are also able to determine ground speed, time to destination. I mean, obviously GPS is the best system out there, but you shouldn't rely blindly on a GPS because, again, it's really, even the FAA doesn't like it too much because it's not directly under their control. It's still under military control. They're the ones that maintain it. They're the ones that own it. And at a moment's notice, they could shut it down for some reason. And if GPS is the only way that you know how to navigate, you've got a problem. So still, use it as a backup. Use it as a tool. Don't make it a crutch. because if you rely only on GPS and if you fly all the time just using GPS, maybe it will never go down. But if it does go down, you've got a serious problem. So keep using your VORs, keep getting familiar with your older instruments, and use the GPS as a tool to aid you in staying ahead of the airplane. The GPS constellation is comprised of pretty much 30 satellites. And for you to be able to receive, we said we need 4, but you're pretty much guaranteed that any point you are on the world, you will be able to receive at least 5 of them. Therefore, you're able to calculate your position all the time. The GPS receiver also verifies the integrity of the signal. This verification process is called RAIN, Receiver Autonomous Integrity Monitoring. RAIN pretty much predicts whether the satellite will be working, whether your GPS system will be able to receive satellites and give you accurate information or not. We'll go next through the test questions that cover the GPS.